Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where, oh my goodness gracious, we are talking about solving absolute value inequalities. Solving absolute value inequalities. This is as much of a mouthful as it appears. Roar, this is some scary stuff, people. Roar, really scary stuff, okay? So you've got to be ready for it, which means, do you have paper in front of you? Because just observing this is not going to be enough. You're going to want to write yourself some notes, have some models in front of you, not only passively learn this, but actively learn it. Write things down and try some of these things yourself. It's going to make a world of difference. Alright, so we're mixing absolute value and inequalities today, and that's going to make life joyous. So we're going to start off by thinking. I know, that's rough. This says the absolute value of x is greater than 10. For those of you not paying attention, you probably think this says 1 times 1. No, this is the absolute value of x. What is absolute value? This should be review at this point. This is distance from 0. We're saying I've got something, x, and the distance that this number is away from 0 is bigger than 10. Here's 0. I counted by 5s. Which numbers on this number line have a distance from 0 that's bigger than 10? 5. 5 is not very far. That only is a distance of 5. 10 has a distance of 10. What about 11? Ooh, 11 is more than 10 away. 15? 15 is more than 10 away. So I'm saying starting at 10, not including 10. So we're talking open circle here. Starting at 10, we're going off this direction. Every number here. So not 10 itself, but 10.4 and 11 and 12 and 20 and 536. Every number this direction is more than 10 away from 0. But you can't stop thinking there. What other numbers on this number line are also more than 10 away from 0? Absolute value, distance from 0. Here's 0. What if I go the other way? Negative 5 is only 5 away from 0. That's not very far. Negative 10 itself is 10 away from 0. What about negative 15? Ooh, that one is also more than 10 away from 0. So again, starting at negative 10, open circle, not actually including negative 10, but everything here, everything down this direction is also more than 10 away from 0. So here's 0, I go 10 this way, that's more than 10. Here's 0, I go 10 this way, that's more than 10. All of these numbers are more than 10 away from 0. So what does that mean? How do I write this? I'm going to write this as two separate inequalities. Some of you hopefully recognize this as an OR statement. I've got one going one way, one going the other. So what we are saying here is that I've got x is, let's go with this first guy here. X is greater than 10. That's this guy. X is greater than 10, which really kind of matches what I've got going on here. Because it's a split graph, this is an OR statement. And so what's true on the other part of this? Well, the x's that are going down from negative 10. So I would say that x is less than negative 10. So this is a true statement. I want all the numbers that are bigger than 10. Or any number that is less than negative 10 also works. Both of these are part of my solution. These both contain numbers that are more than 10 away from 0. Okay, what's the difference between these two guys? Again, we said that the first one looks an awful lot like our original. I just took off the absolute value signs. It still has an x, it still has a greater than, it still has a 10. What does this guy have? He still has the x, but where this said greater than, this now says less than. And where this says 10, it now says negative 10. That's always going to be true. When I go to split this into two parts, and I do need to split this into two parts, alright? So take some gymnastics classes if you need to. We got to be able to do the splits here. This is greater than, this is less than, this is 10, this is negative 10. So the first one is almost the same, second one has some changes going on. Why do I point this out? Because our ability to think this through every time gets really difficult when the problems get more difficult. Alright, I'm leaving some space here. There's still one more thing I want to write, but not yet. Second part of this. This one is not quite the same. This also says the absolute value of x, so absolute value of x is less than or equal to, this time, 10. So I did less than and I did an or equal to, just so we can kind of compare. What do we know? Again, distance from 0, what numbers are less than 10 away from 0? They need to be closer than 10. Well, 5. 5 works. 5 is something that is less than 10 away from 0. What about 9? Ooh, 9 right there would also be less than 10 away from 0. This says or equal to. This could actually be 10. 10 itself is 10 away from 0. But again, I can't just think about positives. Think of the other direction. Other numbers are also less than 10 away from 0. Negative 5. Negative 5 is less than 10. It's only 5 units away from 0. Negative 10 is exactly 10 units away. I can pick any number in here between negative 10 and positive 10, and all of these numbers are less than or equal to 10 away from 0. So these numbers are greater than 10, have a greater distance. This is less than, these are close, they are inside, they have a closer distance. If we look at what we just said, we said here that we are doing the numbers that are less than or equal to, because this says or equal to, less than or equal to 10. All right, so that's true. This, what kind of graph is this? If this one is or, this one is and, right? This is an and graph. So I need to be smaller than 10, and what was the second part of this? These numbers here, the negative, if I go bigger than negative 10, I'm also in this realm of being things that are pretty close to 0. So I would say that the x's are greater than or equal to, and again, that's negative 10. So what do I have? The first one, again, I'm splitting this in two pieces. I have to split it in two pieces. I always split it in two pieces. This one here, x less than or equal to 10. What happens on the second one, when we think it through, we find out we still have the x, but we're going the other direction. So if this was less than, this is now greater than. And if this was 10, this is now negative 10. So this is going to be true, and this is going to be also true. All right. Again, I've expressed this idea that it's kind of challenging. If you can even manage to remember that this does split in two, you have to get it split in two correctly, and then you have to know if it's and or. Can I offer you something? Okay? This is a D.A.V.E. This is a D.A.V.E. It's the Doyle Adapted Version Experience. In other words, I made this up myself because I find it helps my brain remember things a little bit. What kind of symbol is that? That is greater, yes? Here's what I want your brain to reconfigure that as. Right now, this is a greater than sign, and I want you to rethink that as great or. Oh, look at that. Greater, great or. If I have a great or then sign, it's an or statement. Great or. Yeah, that's just a nice little memory trick so we can get that in place. So what do we do for this one? Well, what sign is this? This is less than or equal to. I'm going to ignore the or equal to for a moment, but this does say less than. So what we normally think of as less than in our brains, again, let's reword this for ourselves. What sounds kind of like less than? How about less and? That sounds like less than, doesn't it? Less than, less and. So less than is an and, less and great or is an or. That's not too bad. We can remember that. This will always work as long as you've got this absolute value by itself on the left-hand side. So absolute value all by itself, the 10's over there. Absolute value all by itself, the 10's over there. Okay. That was the thinking part. Now comes the more abstract, slightly scary part. All right. I have 4 examples that I have chosen. Why 4? Not because I'm just trying to torture you, but because they actually each have a purpose. Okay, are you still with me? Are you still writing things down? Are you still paying attention? All right, here we go. This, I said, this great or and less and, this works really well as long as the absolute value is by itself. Look at this problem. Do I have the absolute value by itself? Not really. This is absolute value of x plus 6 is less than 8. So if I would like to solve this, I would like to get rid of the plus 6. I do not want to split this in 2 until the absolute value is by itself. Repeat. Do not split, or splint apparently. Sorry about that. Do not split into until absolute, I abbreviated that, absolute value by itself. Okay, just squeezing that up in the corner, but that is going to be an important note. Do not split into until the absolute value is by itself. What did you write? If you don't like what I wrote, you better write something like it. Alright, so we cannot split this into two pieces until the absolute value is by itself. Right now I have a 6 with my absolute value. How is it attached? Through addition. How do I break that? Through subtraction. Subtracting 6, subtracting 6. This is the same as some of our equation solving skills, so this is not super crazy at this point. That drops. Oh look, it's almost like having x by itself, except I have the absolute value of x by itself. This is less than, this is less than. 8 minus 6 is 2. Now this problem looks like these guys. Which means I do need to split it into two pieces. What will the two pieces be? Well, one of them is going to be, let's see here. Sorry, I'm trying to figure out how I want to write this. I'm going to do this, I think. One piece goes this way, ta-tan, and one piece goes this way. They have some similar looking parts to the pieces, but they're still two pieces parts. Just like this went into 2, this here's about to go in 2. So, this says the absolute value of x is less than 2. I'm going to write x is less than 2. Again, my first phrase being awfully similar to the original, I just got rid of the absolute value sign. The second one, if we think about how the second one worked then, we said the second one we're going to keep the x, but if this was less than, we're going to make this one greater than, so that we've got one of each, and if this was 2 here, we're going to go with -2 on this side. Both of these are considered to be pieces to my solution, here and here. Ladies and gentlemen, is this and or? Well, this is a less than or less and sign, so this is one and the other. One and the other. So if I'm going to graph this, what do I expect to see? Hopefully it's something that's going to look kind of like this with these guys in the middle. Number line, 0, 1, 2, -1, -2. There we go. Got a few other things in there. There we are. And so this says, it doesn't say or equal to. So we're just talking open circles right now. So open circle at 2 and open circle at -2. I want to be smaller than 2. That's this way. And bigger than -2. That's this way. I want everything that is in between, excuse me, everything in between 2 and -2, which makes sense because that's what an and picture looks like, and this is and. I can pick any number in here and have this work. 1. The number 1 is in this range. What's the absolute value of 1? 1. What's 1 plus 6? 7. Is 7 less than 8? Yes. Yes, it is. There we go. All right. How you doing? Okay, not done. Not done yet. 3 more examples. All right, look at this next example, and please, please, please tell me your eyes are open. What is the difference between this guy and this guy? This one says the absolute value of x plus 6 is less than 8. This one says the absolute value of x plus 6 is less than 8. Here the plus 6 is outside the absolute value. Here the plus 6 is inside the absolute value. Does this mean I treat them differently? Yes, yes it does. Remember that we said we do not split until the absolute value is by itself? We had to get rid of the 6 to get the absolute value by itself? Guys, the absolute value is by itself. There's nothing else over here, just the absolute value. Yeah, it's got a plus 6 inside of it, but that's okay. That means that right now, we are ready to split. Right now, this can go in 2 pieces, and it has to go in 2 pieces. You've got to remember, absolute value always gets split. So, what does this mean? Well, the first phrase is going to be a lot like the original. We'll just get rid of the absolute value sign, so x plus 6 is less than 8. Notice x plus 6 less than 8. That matches. What am I going to do over here? Well, again, think about what was going on with these guys. I'm going to do the x plus 6 again. So first part is the same. For the second part, we say that we take and we flip over the inequality signs. So if this was less than, this one's going to be greater than. And we change the signs for the numbers as well. So if this was a positive 8, this is going to be a negative 8. Notice the x plus 6 and the x plus 6 are the same. The pieces in the absolute value don't change. It's just the inequality signs that flip and then the numbers on the end that flip as well. This and this look similar. They are different, and you have to know what to do with each one. Now, solve. Minus 6, getting that x by itself. A lot of talking today. This will be x is less than 2. Wait a minute, that's a lot like that one. What about this guy? Minus 6. Is that going to be negative 2? There's my x. There's my greater than. Let's see here. Okay, sorry about that. Needed a drink real quick. Did you figure it out? What's negative 8 minus 16? They're both negative. Negative 8 minus, negative 8 minus 6, not 16, is negative 14. I did not get the same answer. That's because this problem is different from the last problem. Is it still and? Goodness gracious me. This is less than, less and? Yep, this is still an and statement. So I'm looking for numbers that are hopefully between 2 and 14. Smaller than 2, bigger than negative 14. If I'm drawing my number line, I might need it kind of long here. Maybe I count by 2s. That seems like that can make sense. I think that'll work. Let's call that 0. And I'm counting by 2s. So this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Counting by 2s. I didn't squeeze all those numbers in there so that we can actually read it a little bit better. Less than 2. So we're starting at 2, open circle. We're going to go less than. But this is the x's are bigger than negative 14. Again, not equal to. So we want an open circle. And we're going to be bigger than negative 14. So that is everything between negative 14 and positive 2. This is a lot. Your brain will not hold on to all of this at once. What are you writing down? You've got to make notes to yourself why these things are happening. And hang in there. Again, 2 more examples, 2 more. I will try to speed myself up a little bit. The last example is the shortest. Okay, so check this out. I'm going to go with this. Here we go. So what do you think? If we reference our last note, it said do not split until the absolute value is by itself. Do I have the absolute value by itself? Almost. There's a 4 out there. Can I get rid of the 4? How is it attached? That's 4 times the absolute value, so I can divide by 4 and divide by 4, and I can make that go away. So that's gone, leaving me with the absolute value of x minus 1 is greater than or equal to 12 divided by 4 is 3. Again, once I have it to that point that the absolute value is by itself, I am splitting it in 2 pieces. I must remember to split it in 2 pieces. The first piece, almost the same. Keep the x minus 1 is greater than or equal to, keep that, and 3. So the only difference between this guy and this guy is this one has absolute values and I got rid of them. Second piece, x minus 1 stays the same. The part in the absolute value doesn't change. But if this was greater than or equal to, this is going to flip over and be less than or equal to. And if this is positive 3, this is going to be negative 3. All right. Adding 1, getting the x by itself, undoing what we have there. There's x greater than or equal to 3 plus 1 makes 4. And then same thing here, getting that x by itself. We can add 1, undo what is there. X is less than or equal to, negative 3 plus 1 is negative 2. So this piece is part of my answer, and this piece is part of my answer. Wait a minute, I just said and. Did I mean to say and? What sign is this? This is greater. Greater. Ooh, this is an or statement. This or this has to be true. What does that mean for a number line? That means that I'm ran out of space right now, but if I was going to graph this, this would be closed circle on 4 and going greater, and this would be closed circle on -2 and going less. So this graph would look a lot like this one, where it got 1 going one way and 1 going the other way. That's OR. All right, last one. Are you ready? Because I'm about to mess with your brain. I'm sorry, it has to be done. Okay. Here we go. Let's see. Is the absolute value by itself? Because we said we can't split it in 2 until it's by itself. Not yet. So let's do the +3. +3 to get the absolute value by itself. Same thing on both sides. We're undoing the -3 with the +3. And so now I've got the absolute value of 2x is less than, and -8 plus 3 is -5. You know what the answer is? The answer is no solution. Did you know that? The answer is no solution. I get to stop right now. Why? Why do I get to stop right now? Why is that the answer? What is absolute value? Absolute value is distance from 0. So think about this. All right? Distance from 0. Distance from 0. Can I have a distance from 0 that is negative? This is a whole separate discussion. When you very first learned about absolute value, you learned that distances are always positive. All right? I can't jog -5 miles. I can't be -5 or less than -5 away from 0. I can't. So because this is negative right here, that is my warning sign. Dun, 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 dun. That is why I've got no solution. If your brain is not aware of that, you will continue to solve as normal and you'll come up with an answer, but your answer is going to be wrong and it won't work and you probably won't even realize that it's wrong. So let's go back and recheck. Absolute value greater than 10, positive. Absolute value less than 10, positive. Positive, 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 negative. That's how I know it's going to have no solution. I can't continue. I can't be a negative distance away. All right, you cannot give up on this stuff. You just can't. There's a lot going on here, and honest to goodness, you've got to practice until you're comfortable. That's it. All right, enjoy.